Nothing. I just had the. That was my countdown to start the video. Okay, let's get started. So a lot of you guys are going to face some problems right away because you have all those parallel angles formed by parallel lines from yesterday. And guess what's not going away? This stuff right here from Unit 1 and 2. All right, so hopefully you kept your sheet of all the theorems, all right, because obviously these aren't with you when you try to do the assignment on your own at home. Okay, but again, everything we've done from Unit 2, all these postulates and theorems, along with the new stuff from yesterday. So let's get right into it, dive right in. A and B, lines A and B are parallel. Do we remember how to label that from yesterday? Lines A and B, how do I label parallel lines? With arrows, yep. Okay, so A and B are parallel. And if you keep reading in the given, so are C and D. Now, if you want to put two arrows on that, that's fine. Sometimes you won't see two arrows because take a look. The arrows that are going in the same direction signify the lines that are parallel. All right, so if you want to put two on, that's fine. All right, but you may not see two in some diagrams. All right, before we get into it, because I made this, I wanted a nice and easy one first, so I gave you all the statements and you provide the reasons for me. Before we do that, though, let's take a look at my proof statement. Angle 1 congruent to angle 3. Look at angle 1 and angle 3 right now. And I want to make sure that you and I are both clear with each other that 1 and 3 aren't special types of angles. They're not alternate interior. They're not corresponding. They're not anything we talked about yesterday. Here is why. And I'm just going to show you up here. If I highlight angle 1 and angle 3, okay, you could tell me they're on the same set of parallel lines. Everyone agree? They're on this set of parallel lines here. But what's the problem? What's this acting as? If these are my parallel lines, what's this acting as for angle 3? Transversal. If these are my parallel lines, what's this acting as for angle 1? Okay, so do you agree they have two different transversals? No special types of angles are going to be formed on two different transversals. They're always on one transversal. Okay, always on one. All right, so 1 and 3 are on two different transversals, which means they have no special relationship one bit. That's why this is not a two-step proof. Okay. All right, so how do I get there? Well, why is 3 supplementary to 2? Take a look at 3 and 2 right now. Why are they supplementary? Let's go back to yesterday. What type of angles are they? What type of angles? This is where we got to be right now. All right, and this is one disadvantage of not doing the assignment from last night. 3 and 2, Emily, what do you got? Same side interior. Now, hey, hold on. Before we write anything down, this is exactly what I was talking about. 3 and 2. Do you see how they're on these parallel lines here? And take a look. Don't they have the same transversal? That's what I'm talking about. If two angles have two different transversals, they don't have a relationship. If they're on the same transversal, then okay, now they do. And they are what again, Emily? And what do we know about same side interior angles? They are supplementary. So that's why I wrote 3 congruent to 2. So our reason is what we wrote yesterday. Parallel lines. We write the arrow, which means implies. What type of angles again? Same side. Interior angles. And again, that's not just going to be good enough. What about them? Are supplementary. Thank you. Okay, same side interior angles are supplementary. Okay, we're moving along. 1 supplementary to 2. Look at the diagram. Why are 1 and 2 supplementary? Well, they're not next to each other like this, like these two here, so I can't say linear pairs. What type of angles are 1 and 2 now? Let me highlight them. Maybe it's easier if I highlight them. 1 and 2. Here are the parallel lines. 1 transversal. Are they inside or outside? Inside. Here's the transversal. Same side or alternate sides? So again, just like 3 and 2, what type of angles are they? Same side, interior angles. So parallel lines imply same side interior angles are supplementary. Got it. And this is why they're tough. 1 congruent to 3. It's not going to start out with parallel lines for your reason. Anything goes here. Anything. This has nothing to do with the lines being parallel 1 and 3. Look at what we did above. Look at what we did above here. Look at what we did above. Try to match up here. Let's go, Sean. Oh, my heart. My heart. Substitution, remember, is only for if they were, hey, if I do this, Sean, put an equal instead of supplementary, you're 100% correct. You're going to take it now, Mike?
Supplements of the same angle.
Ready? Take a look, everybody. What's 3 supplementary to? 2, and what's 1 supplementary to? The same angle. Both of those are supplementary to the same angle, so they're congruent. And again, this was our Unit 2 theorem, which said supplements of the same angle are congruent. Whew, that's that last reason there. Had to use something from a previous unit. And some of you may say, well, this doesn't seem that bad. And of course, I gave you the statements. All right, what if you have to start from scratch? Which we will now. Any questions on these right here? Going? Okay, I am going to skip over. All right. All right, let's keep it going then for 3. Okay, here we go with number 3 now. Now we are starting from scratch. So I'll give you guys a minute right now. Go ahead, write down the givens and mark your diagram appropriately, please. I'm hoping we're at the point now we can mark angles correctly. And while you're waiting, look at the prove statement. Make sure you can find those angles. Make sure you can recognize the angles we need to prove congruent right now. All right, we ready to take this over now? Okay, this is where we get it gets a little tougher. Everyone's got everything marked correctly. Take a look up on mine. Make sure we got CDA and BFE marked correctly, and then the parallel lines we need. Everyone see the 2 angles I'm trying to prove congruent. Let me just highlight them real quick. This huge angle right here, CDF, along with the DFE, this angle right there. So those 2 angles we need to prove congruent somehow. Well, we know part of them are congruent, right? Where it's a start, right? That's a start. First off, let's get this out of the way so it doesn't, because some of you may think this is a 2-step proof and it's not. Here's what I'll get. Oh, these angles I've highlighted in yellow, those are alternate interior. Everyone agree? They're alternate interior angles. Opposite sides of the transversal inside the parallel lines. What's the problem here? What don't I know about CD and FE? I don't know they're parallel, so these are not. Yes, hey, take a look. These 2 are alternate interior angles, but they're not congruent. Why not? I need to know what. I drove home this point yesterday. I need to know what about the lines for them to be congruent. They're parallel. These lines are not parallel. So therefore, these alternate interior angles are not congruent because of that. Do we see that? Okay, well, I do have a pair of parallel lines up there. How can I use those now? Are there any types of angles you see now formed by those parallel lines? Here are the parallel lines cut by transversal DF. Do I see any special types of angles up here? Will, let's go. Alternate exterior. Where would they be?
Well, if you extend both parallel lines, would FEB or EBF or EFB and ADC be?
Well, they're already congruent because they're given.
Oh.
Do we see any types of angles up there, guys, that are familiar from yesterday? Here's parallel line AD. Here's parallel line FB, cut by transversal DF. Emma, do you see anything? Which ones? Name them. Name them. ADF. Ready, everybody? ADF and DFB. Does everyone see? Those are alternate interior formed by the parallel lines FB and AD. And Emma, since the lines are parallel, what do I know about them? Are those the supplementary or the congruent ones? Congruent. Perfect. So angle ADF is congruent to angle DFB. Reason from somebody else. Remember, these are your explanations from yesterday. What would you have put? Well, what did I start out with? Sean? Well, okay, ready? Parallel lines imply what type of angles do I have? Perfect. Alternate interior angles are congruent. Okay, well, how am I going to get to the big angles then? Take a look again. Need this angle congruent to this angle. Staring you right in the face, Cameron. Addition. Whoa, watch your mouth. What do I always ask you if before? Do you have two pairs of equal quantities to add? Yep, given. I gave you one, and then Emma just found the other pair. All right, so I can add. So Cameron, since you're on the adding phase there, give me a pair of angles I'm going to add together. ADC plus ADF, yep. And that'll be equal to the other pair, which would be BFE plus BFD. And that is by addition. It's not going anywhere, unfortunately, guys. Sorry, it's not going anywhere. And then what do we usually do after addition? It's not changing. That's one good thing, at least. Always stays pretty consistent. Okay, so again, if you are given parallel lines, look for the special types of angles, which in this case happen to be alternate interior. Questions from you guys there? We got one more to do together, and then I let you go on your own. Ready? As you're setting up your givens, see if anything stands out to you. Hopefully it does. As you're writing down those givens, something stands out big time. Is anybody noticing anything as you write down your givens? What we talked about from Unit 2. Anybody see anything you wrote down in your givens? You're like, whoa, hold up. This may be this type of proof. Okay, you're getting there. We're getting. Thank you. Yes. How many angles are getting bisected, everybody, in this proof? 2. More than 1, right? That's what we need. As soon as I see 2 angles being bisected, ding, 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 halves of equal quantities. But, hold up. It's not going to be 2 steps here. Halves of. Do I have any equal quantities up there? No. So what you're taking half of, everyone agrees we're going to take half of JEB and angle EGD. Look at the diagram. Tell me something about those 2 angles for me, please. Look at JEB and look at EGD. Please tell me something about them. Go ahead, Heaven. You're darn right, which would make them what if the lines are parallel? And there's your equal quantities we're going to take in half. All right. What you take in half, JEB and angle EGD, what we're going to cut in half have to be congruent for you to use halves of equal quantities. And they are. And if you just listen to what Heaven said, she said, hey, lines are parallel, so parallel lines imply what type of angles were they again? Corresponding angles are congruent. Perfect. Anybody put 2 O's in corresponding? Self-respect. Can I go right to halves of equal quantities, or do I need something else? What's the first word in that theorem? What's the first word in that theorem? Halves. Have I mentioned half of anything yet? Okay, we better mention that then. So half of, which angle am I going to take half of again? Pick. Oh, JEB, thank you. Is equal to half of JEB. So if I look up at my diagram, look at yours too. If I take half of JEB, I can either go JEF or I could go FEB. But only one matters to me. Which one? Because it's in the proof statement. Perfect. Angle FEB. And go on the other side now and take half of EGD. And that'll be the same as HGD. Ooh, reason? Because we're not halves of equal quantities yet, are we? Why don't you settle down and let some of your classmates talk there? Mike?
Would it be definition of a bisector?
It would be. 1F. Now, if I take halves of equal quantities, they will also be equal. So now we can write halves of equal quantities. Magic. Questions from you guys on that? I want to remind you that I put my hold on before we get going. I put my versions up on Aspen from the homework. May not match yours, and that's still okay. All right, don't completely change your proof. Bring it in tomorrow and say, hey, is this still okay even though it didn't match yours on Aspen? On the other hand, don't go on Aspen and just write down the statements and reasons I have. You know that's going to do you no good. All right? So, wow, we got a lot of time. You guys have 20 minutes here to start your homework. All right, because we didn't have an assignment to go over. If you want to get out Chromebooks and look at the answer keys, that's fine too. If you're stuck, call me over. Okay, if you're stuck, call me over.